Hello, welcome to Advent of Code in Liquid Haskell. I believe this is day 9 already. Yes. So, yesterday I did not manage to get both stars on the live stream, but I did manage to finish it earlier this evening. Um, so let me pull that up and review that a second. So I was having problems with the termination checker, and that was a clue to how to simplify it. So instead of making this function was grody and had an inner recursive, and now it's now it's just a composition of other operations. And so we can chat window over. I can see it. Now it's just a fold over a list of highest trees, and we compute the range in a separate function. This is sort of gross. It could probably be improved, but this shows it has the correct type. And I used enum from then too, which has a very I don't know what the right word is, idiomatic interface, and so I built in-range around it. I tried writing an assume just for enum from then too directly, and ran into problems because it's over the enum type rather than arbitrary numbers. So like I couldn't write this because 0 might not exist in an arbitrary enum. So I just wrapped it in a function that only works for ints. So we compute the range of locations we're going to look at. We find the maximums within there where the tree height steps up, and then we just mark those on the map. And that's a lot easier. And some of those can be reused for part 2. So part 2, same idea. So this I did end up writing as a recursive version, because I looked at doing take while, but take while skips the first one that drops the first one that the condition is false on, and we want to include it. We actually want to include that tree in part 2. And so we just compute ranges in all 4 directions, look at what trees are visible, and then compute their score with a Cartesian product of we compute their score, and then we take the maximum over all trees using Cartesian product to take all the x and y coordinates. So I was pretty happy with that. And all type checks and terminates checks correctly, so that's good. I'm a little unhappy that the day 2 is sort of brute force-ish. Advent of Code often has this feel where you come up with something clever on part 1, and on day 2, part 2, the assumption is broken. You have to do the dumb brute force thing that you should have just done in the first place. But I feel like there is some redundant information that if you can see, trees to your left, then that tells you something about how many trees you can see from one right of where you are. And so it seems like we should be able to do dynamic programming for all 4 directions and compute them simultaneously, but I haven't checked their Reddit thread to see if anybody has boasted about their very clever solution. So I think there is room to do something clever, but I did not. So let's get ready for day 9. I was trying to work with proof combinators and could not open the library, so I don't have that to show. Okay. So we're moving the head and simulating the tail based on the behavior. Okay. So we can reuse all our fancy matrix code from yesterday. Simulating the rope, you can count up all the positions the tail visited at least once. All right, let's copy the example. Let's get started. And direction. It's not type. I keep making that mistake. It's data. Right. Up. Left. Down. Okay. So we're going to go from a string to a maybe move. Split by, all right, where's our split by code? Split one up. So we can use the same strategy. So if it's right and then a number, read. Oh, right, yes, right is part of either. So maybe we don't. Maybe we don't want to use that. I don't like the single letters, but maybe. All right, there's our all the parser we need. And let's start copying over some of our vector code from yesterday. It's not a vector. It's not a matrix. Because we could easily move, we don't know how much space we require. So it's going to have to be a map. Okay. This is why I wanted to build a domain-specific language for advent of code problems, because they so often involve, like, you know, these sparse grids where you'd really like to treat them as a matrix, but they're expandable. But well, we need good thing we didn't get any further on that. Okay, so our state is I'm not sure whether I want this like this or have them separate out. Let's try it like this. We could even create a chords type if we were writing nice maintainable code. All right, and so what I want is a map from a pair of not even really a map. It's just a set. Am I going to regret not having a map in part 2? We'll find out. Oops, it's flipped into a different language there. So can we say anything about the specifications? Well, we can say a little bit. I mean, we don't have bounds. So the coordinates are just arbitrary. Oh, better not. What is it unhappy about? Oh. So what we can say is that the tail position should always be in this set. That's a fairly minimal invariant, but it's very unhappy already. Set mem. All right, so that's a good start. So there's another invariant, which is that the tail has to be within one space of the head. Right, so this describes how it happens, but they have to be within one square. So let's write, it's not a Manhattan distance one, it's, I don't know what the metric is called here. Each coordinate separately has to be within one. So let's see if we can write that. And do we need a measure? Don't think so. Might need to introduce. All right, I'm gonna introduce measures for extracting the x coordinate and y coordinate rather than just using first and second. Can we add both those as measures? All right, looks good. So let's write this type. So y coordinate of C. And simplest to do this is absolute value. I could write out all the cases, but let's just do y coord x minus y coord head plus less or equal to 1, and same for x. Unbound symbol. All right. Well, liquid, no, not compiling now. Well, I guess we may be writing it out in the gross expanded form. Huh, why should that be giving us a problem? It'd be really convenient if this worked. This is silly, but I just wanted to try it. All right. Looks like a perfectly good measure to me. All right, so all right, maybe we'll try a different measure. All right, 1 is true. 0 is true. Come on. -1 is true. Everything else is false. What? Oh. All right, how about that? Okay, looks good. So now we need to simulate movement. So add that code type alias after all. So all right, we're going to call this move one step because we're going to have to do multiple moves. Set direction. So we could write out the whole thing as a specification, but what I'm going to do is say the new coordinate has to be within one step, which is not, yeah, that's too loose. Let's do something else. So either the x coordinate is the same or the y coordinate is the same, but not both. So x coord c equals y coord d, or x coord c. I don't think we have exclusive OR operator. And y coord not equal, or let's write it this way. Not direction. Right. Distance. Right, so down, we decrease y by 1. Up, we increase y by 1. Left, we decrease x by 1. And right, we increase. All right. Wow, it doesn't think we got it right. That's odd. It's falling in the within one measure. Which I didn't explicitly ask it, but let me take another look at that. Oh, let's just, no, we got the, there we go. Squared has to be the same and y different, or x not the same and y the same. All right, that didn't help. BCD, all right. Check that those look okay. Yeah, it's a word like that. Maybe I should have called it pause for position, but pause in liquid Haskell is often used for positive integers. Well, I was not expecting to run into so many brain busters, but right, did you give it a type? Okay. All right, so it knows that the tuple oh, I see. So we wrote a measure on an int, so every int type gets that measure attached. That's cute. Yay, well done. Yeah, I was really hoping Liquid Haskell would be helpful today in getting all the conditions right, but stumbling over very simple ones here. So what if we don't treat this as a measure, but we just inline it? Huh. I wonder if that is a bug. Yikes. All right. I may try to reproduce that later. All right. Good to know, I guess. I'm not sure what I know, but I'm... All right. All right, what were I doing before we were wrestling with liquid Haskell? We were going to... All right, I hate this name because I'm going to call the next function move one step. I'm going to call this next position. All right, so move one step takes a move and a simulation state and returns the next simulation state. All right, so all right, so the head's going to move, and now we have to apply the rules that tell us how the tail will move. So if the tail's still within one position, then it doesn't do anything. And if it's in the same row or column, then it just moves closer. And if it's not in the same row and column, it moves diagonally. All right, let's write the function that And the specification for this should be interesting. So tail, y, tail and head. Can we break this into the cases easily? The cases are on the difference. Sure. We've guaranteed that the difference initially is within 1. So now it's within 2. This is really getting cheesy, but all right, coordinate, and then the head is within 2. Should I flip them around? I'm not sure whether I want to do the move or the next position. We'll work on it a little bit. All right, so tail is a coordinate, and it used to be within 1, now it's within 2, which will hopefully prove for us automatically without further assistance on our part. So we could just do this as a big lookup table. We could subtract them. They're only -2 times 25 possibilities. It's either going to be that or a big pile of case statements. Switches. All right. Really like the idea, but I'm not eager to write a 25 long lookup table. I'm gonna actually do positions. And we already know that that has to be within 1. that. All right, so if they're both equal, is there a more idiomatically Haskell way? I mean, there's pattern matching, but do you want? Oh, algorithm ideas. Sure, I'm willing to take it. I'm not proud. Hmm. Yeah, that should work, right? We take the difference. That tells us which direction we have to go in each coordinate. All right. Yeah. Don't need to do cases at all. All right. Yeah. So Haskell have a, not only does Haskell have a sign, it has an entire data signed package. But that's not what I want. I'm kind of confused. What is the point of this package? Well, at least 0 to the power 0 is 1. I mean, great. I'm very confused why this exists. Signum. How intuitive. Signature of a number, sign of a number, and they left out the extra n because that would be confusing. All right. And we're probably going to have to tell. Let's see, we want this to be if h is bigger, then we want it to be 1. So that's the right order of subtraction. And there should be 0. Oops, I'll do y's first. All right. Really? No complaints? I don't believe you. All right, it didn't. There we go. All right. So let's first tell it crap, is this function over integers or something over all numbers? All right, I think we can still work with that. All right, given x in A and y in A, and return z also in A. So z equals 0. All right, if x is no, it's only got one argument. If x equals 0, x equals 1, it'd be really nice if you told me where the parser problem was. Oh, I need else's. I bet. Yeah. Really? That was all it took? Huh. All right. Can we do better here? Can we describe the expected operation more precisely? So we achieved our goal of getting within 1. So I should have just used implied here rather than if then. Oops. We want the x is wrong though unless you get the call to next tail position to only not. So in this case, the sign of this difference is 1, and the sign of this difference is 1, and so we can move up 1, 1, which I thought was what we wanted to have happen. In these cases, this is 0, so we add the sign, which is 0. So I'm confused at why more than a sign. Oh, I see. You're right. You're right. I get it. It's if we just move up like this. This is the case that is wrong right now. Okay. Well, so can we code that in our specification and then fix the bug? Or we could write a bunch of test cases. I guess not because we'd have to write our own version of this. Okay. Thank you for catching that. Yeah, that's a good idea. All right. Sig sign so yeah. Y diff greater than what? Yuck. You did not equal to. All right. Yes. Y diff. All right, so what we're saying is, all right. All right, we better be within 1 at the end, but if then that's not right. That's gonna be that's it. Okay, so if they're both within 1, then no change. Wow, it doesn't agree. It'd sure be nice if it could gave us a counterexample to its inference. You don't agree either with the implementation. All right. Well, that's a good place to start looking then. So if it's okay, yeah, we need to be. See, yeah, I didn't get it right. Both, well, yeah, both need to be checked for both. All right. So, I'm going to do this in a way I can understand because my brain still, I agree with what you're saying, but my brain still hurts thinking about it. So if more than 1 away, then else don't move. All right. Why aren't I getting errors anymore? Oh, x squared t plus sign. All right. No, this has to be or. But if it's 2 away, then we drag the tail towards us. All right. So now it agrees this is correct. And it doesn't agree this is correct. Oh, all right. So it's a specification problem. I use y coordinates both times. All right. Now they agree. Doesn't mean they're correct, but it's a good sign. It's the first time they've agreed, I think. All right. What did I call this? All right. Move the head. Next position. Move of. Next tail equals next tail position of next head and tail position of the simulation. Okay. And we just got to recreate simulation. So simulation with head equals next head, tail equals next tail, and head position, tail position, and tail locations. tail of locations of the simulation, union singleton next tail. So it might already be in there, but whatever it is. Oh, I meant rope. All right, it believes we constructed a valid next location. Let's try that out. So if we had a bug where we does that fail the specification? It does not. All right, now it fails. But it's given us problems up above. So it doesn't believe that the tail position is within 2. Which should just be a matter of math. Double check my definition there. Okay, so we didn't give enough information next position, right? All we said is it's different, but we didn't prove that the new position is within 1 of the old position. So that's what we need to add to its specification. So what does that look like? Okay, so that's the facts that we need, and it checked that. So is it happy there? Looks like it. All right. All right. Yep. See you in a bit, or tomorrow night if you don't make it back. Now, I think the thing that's unfortunate is because of the way I did this, these are all different types. So I'm just going to have to repeat. No, I can fix this. All right. So how do we call? There's got to be a cool Haskell way to all right. Iterate. Iterate. Iterate, move one step. And do it num moves m times on sim. Oh no, no. That's backwards. Function a, yeah, move. Oh, it's backwards. Okay, it's got no, it's got to be move one step of m. So that's a function from sim to sim, and there we go. All right. Great. So start position is a rope with head is 0, 0. Tail position is 0, 0, and tail locations equals set.singleton of 0, 0. And then we need to map map maybe of complete step. Oh no, it's not a map, it's a fold. Two steps. Let's move over the input. And so now we need to, do we need to rewrite this in the other way so we can use the right fold on it? Or is it this fold right? Fold. So move complete state. Yep. And we're going to start with start position and moves. I hope that doesn't do things backwards. Huh. It doesn't appear to know. So it knows it's set as a singleton. But it doesn't know that set membership applies. That's very odd. All right, let's finish writing this, and then we'll see what we can do about that. So what if we make this set.empty union? Wow. All right, that's getting reported as a bug too. We are getting, all right. there's anything I know about set theory, it's that taking the union with the empty set should not make a difference. All right, this is day 9. Oh, I haven't even looked at my input yet. Oh, I didn't define, all right, I didn't define cardinality yet. That is gonna suck. All right, what is it really called? No, I just want data dot set. Oh, why does your search not give me this one? Size. All right, maybe we're not out of the woods yet. Yeah, all right. So the problem is more subtle than that. It doesn't. All right, so we got a problem here. So it doesn't know about, I bet it doesn't know anything about iterate. It does. It knows that it's lazy, but it doesn't know that we can take that its length is greater than all positive values. I wouldn't be surprised if its logic didn't have that. All right. Anyway, I think what's going on here is that we have to tell it that it's the same. All right, so yes, the problem is all right. I don't know how we fix this. I think the simplest thing is we just tell it to ignore. All right, we're just going to tell it it doesn't know what it's doing. All right, that was a lot of last minute problems. Mm. 13. 13 is not a good number. Well, let's dump them out and see. See if we can figure out what it is. Okay. All right. Did I get it wrong about where the tail starts? Yeah, that's what I did. Is the head initial state? Yeah, both are at 0, 0. All right. So 0, 0, 1. Starts at negative. Negative 2, negative 1. Yeah, we never exit the quadrant. Something screwy there. Left, right. Using standard coordinates here. 0, 1. Yeah, we go wrong right away. Right, we should be dragging it through 0, 0, 0, 1, 0, 2. So right. Huh. I bet we're doing something. I bet we're doing fold our does it backwards. Crap. All right. Okay. Better. Yeah, I got misled because I had written this in the form that move right required, but fold right required, but fold right actually starts at the right. So I was working backwards to the list. All right, let's get our real input. I hope I can copy and paste all this and don't have to get file sharing working between my VM and my desktop. It's intermittent at best. VMware's been working on it for Lord knows how many years, and all right, right answer. 10 lots. Let's more types of motion are possible than before. Yeah, the rules for each subsequent tail should just behave the same rules as before. All right, so how are we gonna, they provided another helpful example. Let's copy it. Yeah, I was wondering, can I just chain a bunch of simulations together? That's probably what they mean, is that, yeah, that an intermediate node can be dragged in a diagonal direction. Okay, so the thing I'm worried about is if we just update the head position. Oh no, they should be all within one. All right, I think we can do this. We'd like to extend this specification to say that they What I'd like to do is say that the head of each simulation is the tail of each simulation is the head of the next. So can we say this? So if S is greater than 0, no. It's a for all statement. Okay, we can do this. We can do this as a list, a special list. All right, so is either our chain So we would like to say if the remaining sim is non-empty, then its head position equals the tail position of the sim ahead of it. But so we need to define a measure so we can even say whether it's empty or not. Uh, So before I made a distinct list, and there I could just change the type of the construction. Okay, so what I could do, I could do this. So then I would always have a sim to work with. I'm not in love with this, but it removes the need to come up with some other way of telling is it empty or not. Let's try this. We have to define a measure. But I think they don't have to be defined in order. So let's try this. So the type is so if S is not empty, then the head position of S equals the tail position of the head simulation. All right, that does not look like that works. Let me just try one more thing before we go back to doing it the other way. Crap. We already got that. We already got the type I was writing. Oh, all right. So this needs to be no, it doesn't look good. I mean, we could just do it as a list and it'd be fine. But I really want to establish the relationship between them. All right, so let's go back to the all right, so I wonder if part of the problem is we're using headsim in two different ways here. Trying to use it as a measure and as a variable. So we may still have to fix that. Yeah, can't. First is a bad name, but first sim from just. Tail pause. All right, that did it. Maybe the other way could have been made to work too, if we'd introduced this helper. All right, let's build. Let's build the start position. All right, so if it's 1, then it's a chain of start position with nothing. So assume part 2. Yeah, it doesn't know that they are the same, which is a reduction problem. We didn't tell it that they are all start position, I think. And I'm not sure even start position didn't give it a type. That's not going to be sufficient. They are pairs, so it should be able to compare them itself or just use equality, but sometimes I think it doesn't look. But that's the advantage of using pairs is that's something that the SMT solver should know about. All right, so I was wondering, so I was hoping is if I took origin out, all right, this still works. So I can say this is not just any sim. This is a sim whose no import, not import. I keep making that mistake. I don't know what import does. That's a little eccentric. It doesn't know that the two ways of making a tuple are the same. I am not going to write into coordinate record type just to make this work. We're just going to push on. So yeah, it knows lots of things about 0, 0, that it's a tuple, that every element is 0, but it doesn't know that that is what you get when you apply comma to 0 and 0. 0, comma, 0. We're just getting further into the weeds there. Okay. No, it doesn't like me. It doesn't like that. I don't think the parentheses parse. No, no. All right. So my plan was I would let me copy this error message. My plan was I could tell it that everything in the chain had 0, 0 as its had origin, so they were all equal, and satisfy the requirement that way. All right, let's put this back. I guess having origin not in the specification language was fine. Right, it knows that whatever it is, it's the same everywhere. So we can take that approach here too. Right, so we can say make a copy of it. So we'll do termination error. Really? N is decreasing. Yeah, that's the problem. Okay, now we have multiple types of errors. Oh, no, we need that. So from just V should be tail. So this is first sim of tail. First sim and head sim are not the same thing. I mean, they are. It just doesn't know that they're the same thing. This is an interesting puzzle, but I don't think you're going to be able to solve it. It would be nice to have them all lined up and make the assertion about their structural relationship. But it's getting late. Can we? All right, no. So we'd have to. Okay. It does, but we don't know that head and tail are equal. So not sure that will help, but. Maybe if we make a deep copy. No, all right. Comment that out. And we'll start over with it's just a list of sims. All right, so let's repeat repos. I've used this several times. I cannot keep its name in my head. Replicate. Like Star Trek. Kate. What? Oh, all right. That was a fly make, not catching up. Take our list of sims, and we're going to we're gonna build one step first. All right, so we want to move the first one and then copy its tail to the next one and move that. So we should be able to just move. I could probably write this as a fold, but let's do it recursively. Now our base case should look like that. So this is going to be the rope who's so we already moved the head. but we need to update the tail. Did it? I don't think it type checked. So I'm really worried about all this type checking. Two locations. Because if we could get this to work, then the knowledge that the preconditions were met would all be how many? It should be less than or equal to the sum of all the moves, but how much less than or equal to? Yeah, that's considerably less. Right, because when we update the head, we really need that relationship. Well, that's pretty good. Okay, so we can verify at runtime that this is the case to keep the checker happy. All right, let's give it a try. No, so we need to signal that the head is different. So feels like there should be a way to unify these. All right, so we're going to take the first two. We're going to adjust the head in the same way we did before. Then we're going, all right, so we're going to move the so that's the line that's going to give us problems. Right, then it should complain that we haven't proved that bigger problems. But it really doesn't like what we did there. It was a mismatch parenthesis. First colon. So why isn't it yelling at us? Is it because we didn't have a specification? Or, and we're not calling it yet. So it's probably inferring false. Let's fix one thing here. I'll say this is only going to be called on greater than equal to 1. Neat. That's cool. It's a histogram of how many positions each chain in each knot covered. I really don't think this should be working. I was really expecting to have to check if this relationship held. All right, let's keep going. All right, so what we're going to do is call move one step with our move in X, and then call all right. This should take a head position. And we can clean this up. All right, so we're going to pass in what overwrites the head position, calculate the tail, update the tail. We better save our, and then move the next one to our tail position. Now it is yelling at us that these types are not within the distances you required that they are. do this in the other order so we can make that guarantee. All right, we're going to just dynamically check. So if within okay, so if thin2 next tail position y code minus all right, so if they work, we can recurse, otherwise we're gonna give up. And okay, we can't make that guarantee. All right, we're gonna stop. Okay, we don't need that. All right, so this is something we GC offers a helping hand here doing all this for you, except it's not. Is this new in 9? So Liquid Haskell says, hey, your code should never error out because I'm checking it for you. Well, crap. All right. So to move a single step, we're going to move the head a step, and then we're going to have new head and move the entire tail to the head position of that new head. Move tail N. Okay. So we should just have to iterate again. Move one step. And great. All right, move complete step N of start pause and how many knots do we need? So we need, it's really easy to introduce an off by one error. I think we need 9. So that will give us head and 9 tails. Okay, same problem here as last time. Doesn't know that the list is infinite. All right, and we need to take the last element of the list. What is the Haskell? Last. Says, how do I know that you didn't give me an empty list somewhere? Can we simultaneously give it a type and ignore the failure? It doesn't look like it. We can do the specification here, which we might just have to assume. Okay, better, no better. All right. All right. That's not. All right, let's try it out on the tiny example. Okay, as expected. Let's try it out on the bigger example. Nope, did not work. 0011. This is 13. All right, I guess I need to. Two. Don't really want to write a Haskell program to print those out. Maybe I'll do it in an easier language, like Python. 10 knots? 10 knots? Oh, sorry, I didn't hear the chime when you told me what I was doing wrong. Well, it's easy to try out. All right, that number is right, but why? Okay, so the head contributes 1 knot. Its tail is the same as the next head. Why is it so hard to avoid off by 1 errors? All right, so if I have 4, then there are 5 knots. 1, 2, 3, 4, 5. Do I have an off by 1 error? All right, let's give it a try. All right. Well, thanks for setting me straight. it's too late for me to understand why why I can't get my head around this. Well, let's see if the code works. That's the right answer. Because with one stimulation, you have a head and a tail, which is 2 knots. And with 2 simulations, you have 3 knots. So why do I need to go to 10? That's a good thought. Yeah, do. All right. Well, thanks for your help. I appreciate it. I should really do these earlier in the day, but I have to work during the day. What does move tail end look like? So move tail end takes the new head position. Swaps in the tail position calculated from that, and the old tail position. Does the union with next tail, and then it recursively calls on the rest of it. Yeah, 2 steps, 2 knots. Yeah, something. Yeah, it's oh, well, yeah, there it is. Uh, I was moving the first element, the tail. I the first two segments were moving in lockstep. So it should have been the tail. All right. So now if we, all right. Now if we do 2, we should get different behavior. There we go. All right. And so if we move this up to 9 copies of the simulation, which is 10 knots, then we should get a whole number back. Yes, 2405. All right. Yes, that was the off by 1 error, that the second element of the list was shadowing the entirety of the first element of the list because I switched head and tail. Boy, it would sure be nice to have an invariant on that list. I don't know. I don't know what it would take to do it. It has been a fun one. I think what we might be able to do it is give a type that says type of sim, and then say the head sim has to be that type, and the remaining has to be the type of sim. Okay. The type of sim that has its head position of x equals tail position of head sim. So I think something like that would work, where we encode the restriction on the type. I had sort of thought about that and dismissed it because I thought it would have to apply all the way down, but it doesn't. We just say it's a slightly different type, but I don't know if we could push that all through. Yeah, I liked that, in part 1 we really and again, this is mainly my difficulty in coming up with the right thing, so thanks for the help there. But our specification is pretty good, and it, when they finally agreed, we had the right code. Yeah, all right. Good night. We'll be back tomorrow for more struggles. Sign up. Yes. All right. Good night.